Hello everyone. So in this video, we'll be talking about horizontal asymptote. Okay, horizontal asymptote in this video, in short, I'll be calling it as HA. HA is when x approaching to infinity and the function equals to a constant number, then y equals the number is called the HA. Consider the simple function fx equals 1 over x. When x is approaching to infinity, the function is approaching to 1 over infinity, which is about 0. Okay? So the HA is y equals 0. Right here. This line. Okay? Question: is it possible for a horizontal asymptote to pass through the graph of the function? Okay, so the conclusion is that it is common and perfectly okay to cross a horizontal asymptote through the function. Through the graph. Okay, you need to remember that. Here are some exercise and for limits and continuity. We'll do few of them. Okay, like maybe we'll pick 2 from evaluating those following limits, and 2 from P2 and 2 from part 3. Okay, so a lim x squared minus 4x plus 4 over x squared minus 4, x approaching to 2. Okay, so the domain is x not equal to -2 or 2. Okay, but we can manipulate this function lim x approaching to 2. X squared minus 4x plus 4 can be written as x minus 2 squared. Okay, x plus 2, x minus 2, then we cancel this part, equals lim x approaching to 2, x minus 2, x plus 2, which is equal to 0. Okay, and b lim x approaching to 0, x plus 9 minus 3. Okay, here's a square root. Okay, for this kind of problem, the first thing we need to do is to take out the square root from the denominator. So we time square root of x plus 9 plus 3 on the denominator and the numerator. Okay, equals lim x approaching to 0, x times square root x plus 9 plus 3, then the bottom the denominator is x plus 9 minus 9, which is lim x approaching to 0, x square root x plus 9 plus 3, and the denominator is x. Then we can cancel x, which is lim x approaching to 0, square root of x plus 9 plus 3. So the answer is 6, because it's square root of 9 plus 3, which is 3 plus 3 equals 6. Okay. Part 2. Evaluate the limit by using properties of limit. Okay, so a lim x approaching to 1, 2fx plus half of gx. Then we use this rule right here. This rule is lim x approaching to 1, 2fx plus lim x approaching to 1 over 2 gx. Then again 2 times lim x approaching to 1 fx plus 1 over 2 lim x approaching to 1 gx. Okay, then we know these two numbers from the question. So it is 2 times -5 plus 1 over 2 times 4, which is negative negative 10 plus 2, which is negative 8. Okay? B, lim x approaching to 1, 2 minus fx, x plus 4gx. Okay? We can write this as lim x approaching to 1, 2 minus fx over lim x approaching to 1, x plus 4gx, which is equal to lim x approaching to 1 of 2 minus lim x is approaching to 1 fx. Okay? Then for the denominator, it is lim x is approaching to 1x plus 4 times lim x is approaching to 1 of gx. Okay? Then we put the numbers in, which is 2 minus negative 5 over 1 plus 4 times 4. Okay, so this is 16, 17, 10 over 17. Sorry, 7 over 17.